Hi, this instructional video is about graphing linear equation using the x and y intercepts. So here's an example of one equation. 3x plus 2y is equal to 12. You see, in an equation, if you see both x and the y, that means when you graph on the coordinate plane, somewhere along the x-axis, you will see a line going through the x. And if you see a y, somewhere along the y also means it's going to go through the y. So if you connect the 2 points and draw the line through it, you will have a slope of some kind. So if you see x and y, it will be some sort of a sloped line. So where exactly on the x and the y will the line go through on this equation? Well, that's what we need to find out. And to find it, we first say let x equals 0. Let x equals 0. So here's what you do. Let x equals 0. So when you do, it means you substitute the x with the 0. And what you end up with is, since anything times a 0 is 0, it's gone, you're left with 2y is equal to 12. And to solve for y, you have to divide both sides of the equation by 2. So where will the line go to the y-axis? 12 divided by 2 is 6. At the 6. So the y-intercept is 6. And you do the same thing. This time, let y equals 0. So let's do it a little easier. When I say let y equals 0, you're going to make that y into a 0, which means 2 times 0 is nothing, so you just cover it up. So what do you have remaining? Is 3x is equal to 12. So 3x is equal to 12. Now you're going to solve for x by dividing the coefficient 3 to both sides. So when you do, 3 and 3 simplifies to become 1x, or simply x. And 12 divided by 3 is 4. And that's going to be your x-intercept. The line will go through the x. So those are 2 points on the x and the y where the line will go through. And now we could actually draw that graph. Again, where will the line go through the y? At the 6. 1, 2, 3, 4, 5, 6. Boing. And where will we go through the x? At the 4. 1, 2, 3, 4. Boing. And since you need just 2 lines to draw a straight line through it, there is our slope, our line. This is our graph that represents the function, the equation, 3x plus 2y is equal to 12. Ta-da! Now you could try that one. Good. So you said, same thing. I'm going to do what you did over here and say let x equals 0. So let's use that trick, the finger trick, okay? When you let x equal 0, 12 times 0 is nothing, so you cover it up. So what do you have remaining? It's just a y. Negative 4y is equal to 96. And to solve for y, you divide both sides by the coefficient negative 4. So negative 4 negative cancels to become 1y, or simply y. And 4 goes into 96, negative 24, I guess, huh? That was a long pause there. Okay, so that's the y-intercept. And then you do the same thing with the y. Let y equal 0. So using that finger trick, you're going to let the y equal 0. That means negative 4 times y is 0 is gone. So now you have 12x is equal to 96. Divide the coefficient 12 to both sides. 12's cancel. So x is equal to, well, 12 goes to 96 8 times. So those are the 2 points on the y and the axis the line will go through, or they're called the x-intercept and the y-intercept. So here is the coordinate plane. And this one is going to be so huge, let me condense it. X is 8. 4, 8. Okay? And it's going to go through that. Y is 24. Well, if this is 8, this is 8. This is 16. And this is 24. Those are the 2 points where the line will go through, and I could draw my line to those 2 intercepts. And this is the graph of this equation, 12x minus 4y is equal to 96. Okay? Now,
Banzai!
yeah. Now I want you to try this one and that one. Good. So you said, let x equal 0. Very good. Let x equal 0. Using my finger trick, cover up the x term. So that's going to be a 0. That leaves me with y is 36. Well, that was easy. And do the same thing. Let y equal 0. However, this one you have to do some work. When you cover up that y, because it's 0, you end up with negative 9x is equal to 36. So let's write that. Negative 9x is equal to 36. To solve for x, divide the negative 9 to both sides. Negative 9 reduces to 1x, or simply x. And negative 9 goes to 36 negative 4 times. So those are my x-intercept and the y-intercept of this equation. And I could graph that. Again, x is 1, 2, 3, 4. Bam! Negative 4. Y, 36. So let's just say somewhere here, up here. Okay? 36. Way up there somewhere. So if I draw it, this time we're going to have a line going upward from left to right. Okay? And finally this one, go ahead. Alright. Now this one, later on you'll realize is called slope-intercept form, and there is another way to graph this. But we could still use the x and y intercept to graph this. Again, like before, let x equal 0. When you do, put the finger around the x term. So y is equal to 9. That wasn't too bad. Y is equal to 9. So now it's only fair you let y equal to 0. Now something funny happens. See that y is 0. So when I cover it up, all you have remaining is what's on the right side of the equation, negative 3x plus 9. But remember, I said let y equal 0, so put a 0 there. And you solve for x. And the way you do that here is minus 9 to both sides of the equation. So 9, negative 9, additive inverse, they become 0. They're gone. So all you have on the right side of the equation is negative 3x. On the left side, 0 is like saying you have nothing in the bank. And you take out $9, guess what? You owe the bank $9. Now you solve for x by dividing the coefficient negative 3. So negative 3 and negative 3 simplifies to become 1x, or simply x. And negative 9 divided by negative 3, they're both negative, so it becomes positive 3. So here's the x-axis, x-intercept and the y-intercept. And we could graph that as well. And let me do a little quick sloppy job here if you don't mind. I'm running out of space. Okay, here's the x-axis, here's the y-axis. The x-intercept's 3. 1, 2, 3, bam! Y is 9. 3, 6, 9. Bam! And so we have a line going down from left to right. Later on, we're going to say this has a negative slope. When it goes down from left to right, negative. Positive. Positive. Guess what? Negative. There you go.